we're gonna over the integral by tabular method. The first question, we want to evaluate the integral of natural log of x dx. When you are using the tabular method, all we put is column of signs, derivatives, and integrals. So the signs, we start with a positive, they are alternating, negative, positive, negative, like that. Now from here, we are going to look at the two functions which are multiplying here. We have got a natural log of x, but we also have a 1 which is there, which we can't just see. So we can choose to put a 1 here, natural log here, or we can put a natural log here and a 1 there. So what to determine is which one is simpler if we take it. If we put a natural log here, it will be very tricky. Why? Because even the question itself has asked us to find the integral of natural log of x. And so if we put natural log of x under the integral, that is going to be not easy to work out. And so we're going to put the integral, the derivative, the natural log of x under the derivative, and the 1 will put it under the integral. And we are going to have a negative here, so we get to differentiate natural log of x. Simply differentiate the x, that will be 1 divided by the x itself. That's a rule of differentiating natural logs. If you integrate a 1, you simply get x. So we see that if we continue integrating x, the power will continue increasing. If we continue differentiating 1 over x, the power also continue increasing. So we can end here and simply cross multiply in the diagonal and also horizontally. But we need to know that whenever we multiply horizontal, we need to add integral. So we are saying the integral of the natural log of x dx is going to be equal to, if we multiply natural log of x by x and also by a positive, that will simply give us x natural log of x. We have got a negative, multiply this, also multiply that. So I'm going to put that negative here. Because I'm multiplying horizontally, I'll put integral. So if I multiply 1 over x by x, that will give me a 1. Because I'm integrating, I'll put dx with respect to x. So this will give us x natural log of x minus the integral of 1 is simply x. So just add the constant of integration, c, that is going to be the integral. Second one here, evaluate the integral of x squared sine of 3x dx. So again, I'll put the signs. We have got sine here, we've got derivative, we've got integral. Now what you want to do is to make sure that you put what can be differentiated to give you a constant under the derivative if it is possible. If I put sine 3x under the derivative, however much I try to differentiate sine, it shall never give me a 0. So I'm going to put x squared there, and I'll put sine of 3x here. So this is going to be a positive, and then go to a negative. I will differentiate x squared, that will give 2x. Now to integrate sine of 3x, we take the positive x as the sine, the negative x as negative sine, positive y as cosine, the negative y as negative cosine. Whenever you are moving in the clockwise direction, then you are integrating. In the anti-clockwise, you are differentiating. So when we get to integrate sin, we get negative cos, as we can see. So this is going to be negative cos, the angle is 3x. After you do that, simply differentiate the angle, what you get to divide by. So if you differentiate 3x, you're going to get 3, and then divide by that. So I want to make sure that this is a 0. So I'll again differentiate, that will give me now a constant 2. Now again, I'm going to integrate negative cos. We see if we integrate negative cos, we get negative sin. So that will become negative sin. The angle is still 3x. Differentiate the angle, 3x, that will give us a 3, and multiply with what is in the denominator, that will give us a 9. Again, I'll differentiate, that is going to give me now a 0. If I integrate negative sign, we are saying we are going to get a positive cosine. So that will be positive cosine 3x. And again, differentiate the angle, that will give us a 3, multiply with what is in the denominator, that will give us a 27. So at this point now we can end. So all we do is we'll be multiplying this in the diagonal like that. I wanted to have a 0 here because I know if I multiply horizontally, I'm supposed to put an integral, but if I multiply 0 with anything, it will still be 0, and the integral of 0, that will give us still a 0. So now I'm going to write integral of x squared sine of 3x dx is going to be equal to, I'm going to multiply, there's a positive x squared times that is going to give us negative x squared, and then cos 3x divided by 3. And then we have got a negative 2x multiplied by a negative there, so it becomes positive. That will be positive 2x sine of 3x divided by 9. Then we've got a positive 2 multiplied by this. So that is going to be just a positive 2 cosine of 3x divided by 27. All we do is add the constant of integration, and that is going to be the integral then. Another one here, we want to evaluate the integral of x to the power 4 natural log of x dx. So all we put here is a column for signs, derivatives, and integrals. So whenever we see a natural log, it is very difficult for you to put the integral, the natural log of x under integral, because the integral of natural log of x is not that easy to get. So that's why we would opt always to put natural log of x under the derivative, and we are going to put x to the power 4 under the integral, even when we know that when we differentiate x to the power 4, we can get a constant. But if we put this just in the integral, it will complicate working. So this is going to be positive. All we do now is to get to differentiate natural log of x, that will give us 1 over x. Integrate x to the power 4, that will give us x to the power 5. The same power, divide by that. All I did is added a 1. So now we are getting that the integral of x to the power 4 natural log of x dx is going to be equal to, we multiply in the diagonal, that is going to be x to the power 5 divided by 5 natural log of x, and then we multiply horizontally. But whenever we multiply horizontally, we need to put an integral. There is a negative there, so that will be negative integral 1 over x times x to the power 5 over 5. This x can cancel with 1x there when we multiply, so just remain with x to the power 4 divided by 5. Then we add dx because we're integrating there. That will be x to the power 5 divided by 5 natural log of x minus, I can remove this since it's a constant, that will be 1 over 5, and then integral, what has remained is x to the power 4 dx, and so this will give us x to the power 5 over 5 natural log of x minus 1 over 5. So we integrate now x to the power 4. All we do is add the 1 to the power, that will give us x to the power 5. The same power, divide by it, and then simply add the constant of integration c. Therefore the integral of x to the power 5 divided by 5 natural log of x minus x to the power 5 divided by 25 plus a c. So that is the integral of this one then. Number 4, want to integrate x to the power 2 sine of 3x dx. So same sine, derivative, integral. So for this one, what we are going to do is we are going to put positive here, negative, to continue going like that. But which one are we going to put under derivative, and which one are we going to put under integral? So I want to put under derivative what we can differentiate to give us a constant. So we can put x squared here, and so that means sine of x is going to be here. If we differentiate x squared, we are going to get 2x. If we integrate sine of x, as we saw from the table, sine, negative sine, cosine, negative cosine. As we go in this direction, we are integrating. So if we integrate sine, we're going to get negative cosine. So this will be negative cos x. Again, we're going to add another one. If we differentiate 2x, we're going to get a 2. We integrate negative cos, we're going to get negative sine. and then a negative. If we differentiate 2, we're going to get a 0. Now we integrate negative sign, we're going to get a positive cosine. So we'll end there since we have got a 0 on the derivative part. And we'll be multiplying them in that manner. So what we are saying is that the integral of x squared sine of x dx is simply equal to positive multiplied by this, also multiplied by that. That is going to give us a negative x squared cosine of x, negative multiplied by this one, also multiplied by this, so it becomes positive. So that will be positive 2x sine of x. And then we have got positive by 2 by cosine. That is going to give us positive 2 cosine of x. Now all we do is to add the constant of integration c, so plus c. So that is going to be the answer for this one. Now we have here evaluate the integral of x squared e to the power x dx. How do we go about it? Well, in the same vein, we have got sine, derivative, integral. We'll start with the positive. So what I'm going to do, I'm going to put x squared here because I can differentiate it to get a constant. I'll put e to the power x here. I'll have a negative. The derivative of x squared, that is 2x. When you get to integrate e to the power x, that is going to give you e to the power x again. So all we do is differentiate the power. What you get, divide by the whole function. So if you differentiate this, you'll get a 1. 1, so the whole of this over 1. That will just be itself. And then we're going to have a positive, differentiate 2x, that will give us a 2. This will still be e to the power x. And then negative, differentiate 2, that will give you now a 0. This will still be e to the power x. Okay, so now we can multiply in the diagonals, this by that, also this by that. So what we are getting is the integral of x. Let me just write it mashed down. The integral of x squared e to the power x dx is equal to a positive by this, also by that. That is going to give x squared e to the power x. And then you have got a negative by this, also by that. That is going to give negative 2x e to the power x. We have got a positive by 2 by e to the power x. That is going to give us a positive 2 e to the power x. All we do is add the constant of integration c. So you can see here that e to the power x is common, so we can factorize out e to the power x. We are going to remain with x squared minus 2x plus a 2, and then we simply have a c at the end. So that is going to be the integral for this one. Another one here, we want to evaluate the integral of natural log of x squared. So just as we've been doing everything, so we're going to have sines, derivatives, integrals. Start with a positive. Again, we have got a 1, which of course we are not able to see here. And again, if we put the natural log of x squared under integral, that is going to be trick. So we're going to put it under derivative and a 1 there, and then minus. Now we get to differentiate natural log of x squared. We're going to use the chain rule or the power rule. So we have natural log of x squared. So dy over dx is going to be equal to, first we drop the power, that is going to be 2, and then we write the natural log of x the way it is, drop the power by 1, so that will be power 1, so I can just write it the way it is, and then times, we now differentiate natural log of x, that will give us 1 over x. Therefore the answer here is going to be 2 natural log of x over x, and then integrate 1, that is going to give us only x. So because even if we continue differentiating and integrating, we will not reach to any constant, all we can do is multiply in the diagonal and also multiply horizontally like that. So that will give us an integral of natural log of x squared dx being equal to, if we multiply the positive times this portion times also that, that is going to give us x natural log of x squared, and then from there we have got a minus which is multiplying with the other portion, that will be minus, but because we're multiplying horizontal we put integral. If we multiply this and also that other portion, the x is going to cancel out, so all we remain with is a 2 natural log of x dx. I can remove 2 since it's a constant, so we're going to have x natural log of x squared minus 2 integral of natural log of x dx. So we can see again we have got the integral of natural log of x. So also use again the tabular method to work out it. So I'm going to remove these which are here. I'll now put what I have. So now in this case, I'll put natural log of x here, that is this one, and then we have got a 1, of course, even if we can't see it, I'll put it there. If I differentiate natural log of x, I'll get 1 over x. If I integrate 1, I'll get x. Also multiply them in this manner and also in this way, because even if we differentiate again, we'll not get a constant. We integrate again, we'll not get a constant. So this is going to give us x natural log of x squared minus 2. Now the integral of natural log of x, we multiply these two, we are going to get x natural log of x. And then we have got a minus, we multiply these two, that is going to give us a 1. But because it's horizontal, that will be the integral of 1, then dx. So that is going to give x natural log of x squared minus 2 x natural log of x minus the integral of 1 is x. All we do is add the constant c, and we can distribute simply the 2, that will be x natural log of x squared minus a 2 x natural log of x. This is a negative and we have got a negative inside, that becomes a positive, so that will be positive 2x, and then plus c, which is a constant. So that is going to be the integral for natural log of x squared. We also have the integral of x to the power 5 natural log of x. So in the same way, sine, derivative, integral. Sine will start with a positive. We are going to always put a natural log here whenever we have it. And then we put x to the power 5 there. And then negative. If we get to differentiate natural log of x, that will give us 1 over x. If we integrate x to the power 5, simply add the 1 to the power, that becomes power 6, divide by the same. So we're going to multiply in the diagonal and also in the horizontal. That will give us the integral of x to the power 5 natural log of x dx being equal to, if we multiply natural log of x times x to the power 6 over 6, that will give us x to the power 6 over 6 natural log of x, and then we're multiplying in the diagonal, I mean in the horizontal, so with a negative also, that's why the negative has come. Always put integral in the diagonal. So this x will cancel with 1x there, so we're going to remain with only 5. So that will be x to the power 5 divided by 6 dx. And that will give us x to the power 6 over 6 natural log of x minus, the 6 is a constant, so I can remove it. So that is 1 over 6 integral of x to the power 5 dx, giving us x to the power 6 divided by 6 natural log of x minus 1 over 6. Now if we integrate x to the power 5, simply add the 1, that gives you x to the power 6 divided by the same 6, and then plus a constant c. So that will give us x to the power 6 over 6 natural log of x minus x to the power 6 divided by 36 plus a constant c. So that is the answer. Now we can just factorize out x to the power 6. over 6 because it's common, and we're going to remain with natural log of x minus 1 over 6 plus AC. So here we'll remain with 1 over 6. Here we'll just remain with natural log of x. So, and the last question here, we want to evaluate the integral of x to the power 3 sine of x dx. We have got sines, derivatives, integrals, starting with positive. So for this one, we want to put what can be differentiated to get a constant under the derivative, and that is x to the power 3. And then we have sine of x there. We are going to use a negative now. If we differentiate, we are going to get 3x squared. If we get to integrate sine of x, as we saw from the table, we're going to get negative cosine of x. And again, we're going to differentiate 3x squared, that will give us 6x. If we integrate negative cosine of x, we're going to get negative sine of x. And then minus, if we get to differentiate 6x, we're going to get a 6. If we integrate negative sine of x, we're going to get a positive cosine of x. Again, we want to reach to a constant. Differentiate 6, we get a 0. If we get to integrate cosine of x, we are going to get back sine of x. So at this point now we can multiply in the diagonal like that. So what we are saying is the integral of x to the power 3 sine of x dx is going to be equal to, we have got x to the power 3 multiplying with negative cosine, that is going to be negative x to the power 3 cosine of x, and then we have got a negative multiplying by this and also with a negative, so that becomes positive 3x to the power 2 and then sine of x. We also have a positive 6x cos x, that is going to be positive 6x cos x. Also have a negative 6 sin x. So I've got negative 6 sin x. All we do is add the constant of integration c. And that marks the end of this video. If this is going to be helpful, don't know that you are going to support us is to get to subscribe and also get to share. Thank you so much for watching. Enjoy your day.